Good morning, students. Today we'll discuss short answer question from gravitation. Yesterday, I explained 3 SAQs from gravitation. Last question, Kepler laws of planetary motion. So, one question left from gravitation lesson, Kepler laws of planetary motion. This is the last SAQ from gravitation lesson. Kepler laws on planetary motion. This is the short answer question. Gravitation, you are reading total 4 questions. From gravitation, you are reading 4. From that 4, you can get 1 question. One is escape velocity. Second one, orbital velocity. Next, geostationary satellite uses. Last question, Kepler laws of planetary motion. So, Kepler laws. Law of orbit. This is the first law, Kepler's first law of orbit. Sun located at foci. Planets. Every planet revolving around the sun in elliptical orbit. Each and every planet revolving around the sun in ellipse. Sun location name foci. So, every planet revolving around the sun, revolving around the sun in elliptical orbit. Sun located at foci. This is the first law. Every planet in elliptical orbit, sun location name foci. Second law, law of area. This is the second law. Planet, sun. This is the line. A line joining, this is the imaginary line. A line joining in between planet and sun. This is major axis. So, a line joined in between planet and sun is the major axis. Major axis shows, major axis sweeps equal areas in equal interval of time. This one, 2 ways their statement. Second statement, very simple. Compare with first one. Both are same. What the statement 1 means here? Line joining in between sun and planet is major axis. Major axis shows, major axis sweeps equal areas in equal interval of time. What is the meaning for this one? Means radial velocity of here, aerial velocity, area, here area indicates aerial velocity of radius vector, nothing but dA by dt always equals to constant. Aerial velocity of radius vector always remains constant. Major axis sweeps equal areas in equal interval of time. What is the meaning for that one? Means, for example, you take summer, winter, rainy season. Every season per day nothing but 24 hours. But summer, daytime somewhat more, winter season less. Season to season, daytime, nighttime changes, but overall time period remains same. Like that, here, area of one planet moving from here to here, one planet moving from here to here, we are getting some amount of area. This area, practically same. That's why you write in single word. Aerial velocity of radius vector constant over aerial velocity of radius vector constant. This is the second law. What is the first one? Every planet moving in elliptical orbit. This one we are writing aerial velocity. aerial velocity of radius vector remains constant. Total 3 laws. First law, Kepler laws means 3 in order wise. Law of orbit, law of area. Next one, law of period, time period. Law of period. What is the law of period means? Like this. T square directly proportional to T square directly proportional to cube of semi-major axis. What is the meaning of major axis and minor axis means here? This is major axis. Half part, semi nothing but half. This one major axis, total length 2a. This is the minor axis, total 2b. Our topic about semi-major axis, nothing but half of the major axis. Square of time period, square of revolution time period of planet. Just we are writing square of revolution time period of planet is directly proportional to cube of semi-major axis. So, square of revolution time period of a planet is directly proportional to cube of semi-major axis. This is law of period. So, student, these 3 laws in 3 lines. First, Kepler laws of planetary motion. When you are reading this question, special concentrate on the side headings. Law of orbit, law of area, law of period. Law of orbit, every planet revolving around the sun in elliptical orbit, just like Sommerfeld atomic model in chemistry. Law of area, aerial velocity of radius vector remains same, nothing but constant. What is the law of period? Square revolution time period. Square of revolution time period of a planet. T square directly proportional to cube of semi-major axis. These 3 laws I am giving in 3 lines. Same Kepler laws. Kepler laws of planetary motion, law of orbit. Like this, see, every planet revolving around the sun in elliptical orbit. Sun at foci over first law. Second one, law of area. Aerial velocity of radius vector. Aerial velocity of radius vector remains constant. If possible, you write this dA by dt is equal to constant. Otherwise, leave it. Law of period. Square of time period, because our topic about planets, that's why I'm writing square of time period is directly proportional to cube of semi-major axis. T square directly proportional to E cube. So, student, this is the Kepler laws of planetary motion, law of orbit, law of area, law of period. This one very simple question, 4 marks question for upcoming supplementary examination. Total 4 question you are reading from gravitation. Number 1, escape velocity with derivation. 2, orbital velocity derivation. Next, third, geostationary satellite uses. Last, Kepler laws of planetary motion. From this 4, you can get 1 question for 4 marks because gravitation lesson 4 marks weightage. Okay. Now we are going towards other questions, students. Now see next question from laws of motion. Define momentum, impulse. Define momentum, impulse, state, law of conservation of momentum with examples. This is the 4 marks question. Define momentum, nothing but linear momentum. This question from laws of motion. Laws of motion, last time I explained 2 questions. One is pulling is better than pushing, lawn roller. Second one, method of decrease friction. Other than that, more 3 questions present, student. 3 questions you treat as VSX only because very simple conceptual question but important. In that one, first, total 3 questions from laws of motion. One is define momentum, impulse, state, law of conservation of momentum, examples. First, momentum. Define momentum, impulse, law of conservation of momentum with example. First, momentum, student. This definition you are reading from 10th class onwards. Momentum denoted with P, small p. So, P stands for momentum, M into V. Product of mass into velocity. Everyone they are saying momentum. Product of mass into velocity. Actually, that one formula. But what is the meaning of momentum? In your examination, you are writing like this only. Product of mass and velocity. You are writing like this only because this one simple statement. What is the actual definition for momentum means? Velocity of moving body. Velocity associated with moving body. Velocity with moving body. That is momentum. Linear momentum, angular momentum there. This is linear momentum. Simple momentum. P equals to mass into velocity. Product of mass into velocity. If possible, you write units also. Mass, kilogram, velocity, meter per second. Kilogram, meter per second, momentum. Next, impulse. Impulse denoted with J. J stands for impulse. impulse. Hello, sir. Impulse denoted with J. What is the meaning of J? Means force into time. Force into time. Capital F indicates force. T is the time. Product of force into time. Generally, impulse means large amount of force. Large amount of force acting on the body in small interval of time. Every definition, two ways you go. Simple definition: product of mass into velocity, P equals to mv. Then after, what the impulse means? J nothing but force into time. J equals to force into time. J equals to force into time. Here, student. Now say J equals to force into time. Unit. Force means Newton. Time means second. First, momentum. Product of mass into velocity over. Total 4 words, 4 steps coming from this one. Define momentum, 1 mark. Impulse, 1 mark. State, law of conservation of momentum, 1 mark. Last one, example, 1 mark. For individual 4 steps, you can get 4 marks. Product of mass into velocity over impulse. Product of force into time, nothing but impulse. Explain what is the meaning of law of conservation of momentum. Now, here, here. In physics, anywhere conservation word coming means constant. Conservation, nothing but constant. Law of conservation of momentum. See, if external force equals to 0, generally, diagrammatical explanation, one is M1, one is M2. One is M1, one is M2, moving with U1 velocity, collide with here U2. So, M1, M2, two bodies moving with U1, U2. This one before collision. This one understanding purpose only. After collision, velocity V1, V2, their student. Now, this is the V1, this one V2. Here, what is the meaning of conservation? Means constant. External force in the absence of external force. If we are not applying any force externally, if external force is 0, total momentum of the isolated system, total momentum of interacting particle remains constant. External force not there, momentum constant. That is only law of conservation of momentum. In the absence of external force, total momentum of interacting particle remains same. This one, if in the absence of external force, write like this. In the absence of external force, in the absence of external force, total momentum of interacting particle remains constant. Meaning m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Up to now, 3 steps over, student. One more time, I'm giving explanation. Each and every step, one line, one mark. I will give you in short way. One more time in short way explanation. First of all, momentum, routine concept, this one, product of mass into velocity. Then after impulse, large amount of force acting on the body in small interval of time. Large amount of force in small interval of time. This is nothing but impulse. What is the next law of conservation of momentum? With examples. External force is zero, momentum constant. In the absence of external force, total momentum of interacting particle remains constant. Before collision momentum, after collision momentum, both are same. Momentum before collision, momentum after collision, same. Then after examples. Example means you take VSQ better. Explosion of bomb. Okay, for example, one bomb after explosion going in two pieces, different direction. You know, m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Before collision explosion, initial velocity 0. m1 u1 means before collision, because initially u1 u2 equals to 0. After collision momentum m1 v1 plus m2 v2 plus coming left side minus. Here m1 v1 plus m2 v2 plus coming left side minus m1 v1 equals to minus m2 v2, meaning both momentum, meaning momentum m1 v1, momentum m2 v2. From this one, what we are saying, explosion of bomb, just you are writing after explosion, two pieces, after explosion, two pieces of bomb moving in opposite direction. Just explosion of bomb, enough. Overall, 4 points here. Define momentum, product of mass into velocity, impulse, product of force into time. Next, law of conservation of momentum. In the absence of external force, total momentum constant. Example, explosion of bomb, law, conservation of momentum. One more is there, heavy rifle, not recoil, that VSQ is all. Helicopter there, every question, explosion of bomb is the best example. After explosion, two pieces moving opposite direction, meaning momentum of two pieces in different direction according to law of conservation of momentum. This question now in 4 steps, just 1, 2, 3, 4. 4 concept in 4 lines. Now CR. CR student, first momentum. P. You are writing Product of mass and velocity. Just one word. Product of mass and velocity. This one shortcut student answer MV over. Next impulse. Impulse denoted with J. Product of force and time. If possible, you write units also, that is your choice. Kilogram meter per second, Newton second, because force means Newton, time means second. Momentum 1, impulse 1, law of conservation of momentum, that is the 1. See, if external force is 0, very simple, short word. If external force is 0, total momentum, this one also write like this, P total equals to constant. Meaning, momentum initial, momentum final, both are same. Last example, explosion of bomb. In this one, student, very short way, momentum P, product of mass and velocity. For this step, you can get 4 marks question, 4 schema of evolution points. Next, product of force and time over. Statement of law of conservation of momentum, nothing but in the absence of external force, total momentum of interacting particle remains constant. Momentum initial, momentum final, both are same. Last, explosion of bomb. This is the short way for define momentum, impulse, law of conservation of momentum, examples. So this question from laws of motion, more 2 questions left, student. All the 2 very simple question, more 2 from this lesson, total 5. In 5, 3-star question means 2 only. One is pulling is better than pushing, lawn roller, 1. Second one, method of decreasing friction, enough these 2. If you are reading more, if you want to read more remaining questions from this lesson means, third one, 2-star question, define momentum impulse with law of conservation of momentum, example. Now one more, last 2 questions left, student. Upcoming question, define. Okay, define limiting friction, define limiting friction, comma, dynamic friction, comma, rolling friction. Limiting friction, dynamic friction, rolling friction. Actually, friction nothing but resistance, opposing force. Friction nothing but opposing force. Resistance means very popular word from electricity, resistance. You don't think that one, this one. That one also resistance only. Electric resistance. Anywhere resistance coming opposing. For example, you are going on bike, on road, speed breaker there. That speed breaker indirectly saying decrease your speed. That is opposing friction. So student, generally how many types of friction means? 3. Static friction, dynamic friction, rolling friction. This limiting friction means special case from static friction. But in question, they are asking limiting friction, dynamic friction, rolling friction. First, limiting friction. Limiting friction, nothing but student, maximum value of static friction. Static friction means friction acting in between body and surface in ready to move situation. So in static friction, peak value there. That one only maximum value of static friction we are calling limiting friction. Limiting friction means special case from static friction. Next, dynamic friction. And now, see our student, dynamic friction, resistance offered, resistance encountered, resistance acting, resistance present. Any word, no problem. Resistance acting or resistance encountered by the moving body. Moving body applies some friction on the surface. That is nothing but dynamic. What is the meaning of dynamic? Means body under motion. Dynamic. Dynamic also called kinetic friction. Dynamic friction, kinetic friction, sliding friction, same. So according to our board of intermediate, they're asking limiting friction, dynamic friction, rolling friction. That's why we are going as it is according to our textbook. Limiting friction, maximum value of static friction over. Next, dynamic friction. On the surface. Just friction offered, friction encountered, friction applied, friction acting in between sliding body on the surface. With respect to moving body and surface, what is the friction present? Dynamic friction. Next, rolling friction. You know, road rollers. This one also roller only. You take chalk piece, roller, all cylindrical bodies. Rolling friction. Rolling body on the surface. This is rolling friction. Overall, student, maximum value, peak value of static friction, limiting. A body moving on the surface, friction, dynamic friction. A body rolling on the surface, friction, rolling friction. Three types of friction from this question. Define limiting friction, dynamic friction, rolling friction. Today, up to now, 3 questions over, student. First, Kepler laws. This question from gravitation. So, Kepler laws, total 3 laws, student. Law of orbit, law of area, law of period. First one, law of orbit. Every planet revolving around the sun in elliptical orbit. This situation, this point you are reading from chemistry. Every electron revolving around the nucleus in elliptical orbit. Sommerfeld atomic model. You know, Rutherford planetary atomic model. Rutherford model, we are saying planetary atomic model. What is the reason for that one? Means every planet revolving around the sun in elliptical orbit. Just like every electron revolving around the nucleus in circular orbit. Rutherford said circular orbit, but practically that is not circle, that is ellipse. Finally, why we are calling Rutherford planetary atomic model? Means planet revolving around the sun, just like electron revolving around the nucleus. That's why they suggested Rutherford planetary atomic model. First law of orbit, I gave in short method also, student. Every planet revolving around the sun in elliptical orbit. Sun located at foci. Sun location name foci. Second one, law of area. Aerial velocity of radius vector. Aerial velocity of radius vector remains constant. This one only, a line joining in between planet and sun is the major axis. Major axis sweeps equal areas in equivalent length of time. Overall, that statement you are writing in short way. Aerial velocity of radius vector remains constant. Third one, law of period. Square of revolution time period. Square of revolution time period of planet directly proportional to cube of semi-major axis. First one, orbit. Second one, area. Third one, period. This is the first question for this day. Second one, define momentum, impulse, law of conservation of momentum, examples. What is the momentum? Product of mass and velocity. Product of mass and velocity we are calling momentum. Next, impulse. Product of force and time. Generally, we are going that impulse definition, large amount of force acting on the body in small interval of time. You know, daily life you are watching cricket match. When bowler throw ball, batsman hitting ball, means he was applying force within fraction of second like this. That one only, large amount of force in small interval of time. Product of force and time. Impulse denoted with J. Don't write capital J, student. Don't write I also. Capital J nothing but current density. Capital I nothing but intermediate second there intensity concept coming. Capital I. So, law of conservation of momentum, in the absence of external force, total momentum same. Total momentum of interacting bodies remains constant in the absence of external force. External force 0, momentum constant. Example, explosion of bomb. Just you are writing side heading, explosion of bomb. A bomb after explosion, it moves. Two pieces moves in opposite direction. You are reading VSQ. Two pieces moving in opposite direction because of law of conservation of momentum. This is the question number 2 from this class. Now question number 3, limiting friction, dynamic friction and rolling friction. Limiting friction means maximum value of static friction. What is the dynamic friction? One body moving on the surface, friction acting in between contact bodies. One body rolling on the surface, friction acting in between surfaces, contact surfaces. That is the rolling friction. Limiting friction, dynamic friction, kinetic friction. Last question from this class, laws of rolling friction. 2 laws enough. Laws of rolling friction. Rolling friction, any friction you take, not all rolling. Frictional force directly proportional to normal reaction. Meaning rolling friction is directly proportional to normal reaction. This one we are writing on removing proportional, mu are coming, mu are nothing but rolling frictional coefficient. Frictional coefficient only, but you add rolling word. Number 1, frictional force, rolling friction directly proportional to normal reaction. 2 enough, student. Each and every one step, this one you can get 2 marks. Second one, rolling frictional force inversely proportional to radius of roller. So rolling friction is inversely proportional to radius of roller. Enough this two. If possible, you want one more safe side means right. Rolling friction increases with increase the contact area. Contact area, rolling friction, both are directly proportional. Meaning, rolling friction we are writing like this. Rolling friction increases with increase of contact area. First to enough student, two different steps. You can get 2 marks here, 2 marks here. Last time you got question from this one, advantage and disadvantage of friction. Other than that one, remaining all question, rolling friction loss, previous static friction, sorry, dynamic friction, limiting friction, rolling friction. This is the loss of rolling friction. All this question from loss of motion. Tomorrow we'll discuss other topic. Today I finished total 4 questions. One is the rolling friction, second one limiting friction, static limiting, limiting dynamic rolling friction is the question number 2. Third one is there, define momentum impulse with law of conservation of momentum example and Kepler loss. Out of 4, Kepler loss is the 3-star question, 3-star. Remaining all 2-star question student. So special concentrate on Kepler loss with law of conservation of momentum, impulse, momentum examples. Remaining 2, if possible, you read this questions also 50-50%. Okay, we'll continue tomorrow.